Hello there, and welcome to another Vedic math video. In this video, we're going to be discussing the Nikhilam Navatascaramam Dastah sutra, which means all from 9 and last from 10. And of course, this is straight from the Jagat Guru Swami Sri Bharati Krishna Tirthaji Maharaj's book, which all of the Vedic math videos are going to be based off of. Okay, great. So, when to use this sutra? Well, this sutra helps you multiply any set of numbers very easily. So you could do 4 digits, you got 3 digits, or your classic 2 digits. So just use it to multiply stuff. Let's go into the parts because this is a very broad topic. So I split it up into 4 videos. Numbers close to the base, numbers above the base, mixing both of them, and numbers in between the base. So if you didn't check out my first 2 videos, you should probably go to those first, so this video will make a lot more sense. But welcome to part 3 where we discuss mixing part 1 and part 2. Okay, so basically, let's get an equation here. 12 times 8. What you see here is 10 would be the base. That's what you would think if you're mixing them, and 1 is above and 1 is below. So of course our base is 10. We're going to set up 12 and 8 on our left side, and then have a right side. Calculate, we need left 1 minus base. So this is where it gets a little bit tricky, but you're basically subtracting. So 12 minus 10 is equal to 2. So you're going to put in plus 2 because 10 plus 2 is equal to 12. And then you do the exact opposite for the second number. So 10 minus 8 is equal to 2, put minus 2 because 10 minus 2 is 8. Now you can draw your lines, and as standard procedure, you multiply to get 4. And of course you have multiple ways to get the left portion. And by multiply, I mean 4. So first you could do 12 plus 8 minus the base, so adding both of the multiplicands and then subtracting the base. Or you could add the right column numbers, so including their sign, so plus 2 and then minus 2, and then add the base to that. Or you could cross-subtract, so 12 minus 2, or cross-add, and that's 8 plus 2. All of these should give you the same result. In this case, that is 10. So the answer, for the left portion of the answer would be 10. But you might think, we would typically end right here, but 12 times 8 is not 104. Well, when you're doing this type of variation, there are a couple of extra steps. So what we need to do is take the base and subtract our right portion of the answer from it. So 10 minus 4 is what we're going to have to do. And then subtract 1 from the left portion of the answer, and 1 is standard for everything. Now we draw our lines again, and you get 6 and 9. So 12 times 8 is 96. Great, that's amazing. There is no carrying in this variation. That is something to keep in mind. However, there is a possibility that you might have to add a 0 in front of the right portion of the answer. And let's take a look into that. So we have 107 times 87. Seems a bit random, but you'll see why I picked these. So we're going to set it up. We have our left portion, we have our right portion. Our base is 100. We're going to calculate, so we have plus 7 and minus 13. We draw our lines, we multiply to get 91, and then 94. And all of this multiplication that we're doing here could be repeated by this sutra itself. Okay, but 9,491 is not the answer. We need to keep going. So 100 minus 91, and then subtracting 1, we get 9 and 93. Because 100 minus 91 is 9. But how can 107 times 87 be 939? So this is where the zeros comes in. So the number of zeros in the base is 2, which means the right portion of the answer must have 2 digits, at least 2 digits. So since we can't add a 0 to the right of 9, because that will make it a 90, and that's a completely different number, you add it to the left. Now, and the right portion of the answer must be as long as the zeros. So you add it to the left, and that should give you the same number, 0, 9, and 9, but it changes the answer as a whole. So now the answer is 9,303, which is correct. And that's the only extra thing you need to know. But now we have to go through the limitations. So both multiplicand's bases must be the same. That otherwise you can't go cross base, like you have a base of 10 and you have a base of 100. That doesn't work. And then none of the multiplicants can be a multiple of 10. You might think that works, but when you add the extra step of subtracting from the base, it gets really weird because you subtract 1 from the left portion, which changes it to a 9 typically. So that's basically it. We can jump right into coding. Let's do it. Alright, so let's get started with defining our main function. So I'm just going to call it main, and we might change the name later on. And it's going to take in the parameters num1 and num2, which are our multiplicants. So let's recite the first priority conditions one more time, but it's exactly the same as the videos before. So if any number is equal to 0, then we return 0. If any number is 1, then we return the other number. And if both of the numbers are less than or equal to 5, and I repeat both of them, then we can use the multiple table, which is hard-coded over here. Okay, so let's just code those in really quickly. Okay, so now that those are out of the way, we need to add one more thing here. So we need to make sure that one of the numbers is always going to be greater for consistency, so we know which number gets the plus operator and which gets the minus. So I'm going to choose num2 to always be greater than num1. And to do that, we can first check if num2 is less than num1, then we can do a quick swapping method. So num1 comma num2 is equal to num2 comma num1. And that is going to instantly swap the numbers very easily. Okay, and now let's determine the bases. And we need to use a different method for getting base 1 and base 2. And they're one's from one video and one's from the other because they use different methods. And we need the bases, both of them, to check if they're both the same. So base 1 is going to be using the minus method. So what we did in the first video. So we're going to take string 1. I'm going to do this and then I can explain if you need the explanation. This is exactly the same. So as the previous videos. So we have number 1, which we need to take the string of to get the length because you can't get the length of anything but a string. And then using the multiplication operator, we multiply the string of 0 by whatever this integer is. So if this is 2, you're taking string of 0 times 2, which will give you a string of 0, 0. And then we're joining the string of 1 plus however many zeros we have here using the plus operator, and this joins them together, not actually adds them. And then we take the integer of that to give us a final integer. Now we need to do the exact same thing for base 2, but there is a small change. So coming over here, we're going to subtract 1 from this length. So I'm going to put this into parentheses. So we're going to be subtracting 1 from the length. And this is going to be using the plus method. Okay, so now that we have both base 1 and base 2, we need to check if they're equal. So if not base 1 is equal to base 2, then we can return formula not applicable. I'm actually going to copy this because we're going to use it a lot. So that's our first limitation. The bases have to be the same. So if the bases are the same, then we keep going. And now we come to our second limitation, where the numbers cannot be a multiple of 10. So how do we check that? Well, we use modulo. So if num1 modulo 10 is equal to 0, or num2 modulo 10 is equal to 0, then we can return formula not applicable. So if you didn't know, the modulo is basically a function where you divide and it returns the remainder. So if we're dividing by 10, any number by 10, and we get a remainder of 0, that means it is a multiple of 10. So if you divide 100 by 10, you get 10, and there is no remainder. So that's that, and those are both of our limitations right there. And now we need to calculate the zeros, which we talked about. So that's going to be getting the length of base 1. To get the length, you need to convert it to a string, and then subtract 1 to remove the 1 in the beginning. Okay, so now that we have that, we can actually do the fun stuff. We have to calculate right 1 and right 2, and we already have the left 1 and left 2, which is num1 and num2. So we can say right 1 equal to base 1 minus num1, and then right 2 is equal to num2 minus base 2. And base 1 and base 2 should be interchangeable at this point, but I just like to keep it consistent like that. Okay, and now we just need to get the left and right portions of the final answer, but it's not really final since we still have to do the funny stuff after it. So I'm going to say left answer is equal to num1 plus right 2. You could choose any other way. This is cross addition. And then right answer is equal to main right 1 and right 2. So we need to multiply to get our right portion of the answer, if you recall. And since we're not supposed to use the multiplication operator in the sense that we're actually multiplying two integers, we need to recall our function and create recursion. Now, there is an instance where, because of recursion, the right answer could end up being formula not applicable for either one of these cases. So we need to handle that appropriately. To do that, we can check if right answer is equal to formula not applicable. Then we just return formula not applicable. That's just a quick check to make sure that that is taken care of. Okay, and now we get to do the funny stuff, which is really just two lines. So right answer is equal to base 1 minus integer of right answer. Base 1. Okay. So that we're basically just doing what we did before and taking the base and subtracting right answer from it. And I put it as an integer just to make sure, just to safeguard. It just, puts you in the right mind. Okay, moving on. To do left answer, it's always going to be 1. So we're always subtracting by 1. So you can say minus equals 1. Alright, and then there are instances where right answer is less than 0. Those would get negatives, but they are strange. We might discuss them in a future video. But for now, we're going to stay out of negatives and stay positive. So we're going to just return formula not applicable if the right answer is less than 0. Alright, and now we just need to take care of the actual adding zeros in front to make sure everything is correct. So while, and this is taking the length of right answer, is less than zeros, we need to make sure right answers is equal to 0 plus string of right answer. Okay, and technically it should already be a string, but I just put that there. It just makes me feel good. I don't think you need it there. But now we're done with everything, and all that's left to do is to return the final answer. And it has to be an integer, and we're going to take the string of left answer, and then add the string of right answer. Again, I'm putting the string because it just feels consistent. So we have right answer and left answer. And there we go. And we have our multiple table. We are ready for testing. So I have my test code right over here, and I can just copy all of it. We could do some manual testing, and we can do some exhaustive testing and get another graph. Okay, so num1, num2, let's see, we could put 15, 8. And of course, if you're not familiar with this code, it basically, we run our function to get the answer, and then we print it out. And then we check it against Python's normal multiplication operator and check if it's correct. And then if we do get a recursion error, we can print out the error and why and check if what's wrong and what's happening. Oh, looks like I made a bit of a typo here. Let's go up to the base. Okay, so this parentheses is misplaced. My apologies. Okay, so we can't take the length, we can't subtract from a string, so after we get the length, we subtract -1. Okay, let's give that another try. Alright, and now you can see that we get 120, and is it correct? Yes, it is. 15 times 8 is 120, that is working. Now, I'm not going to do more manual testing because we should get to the exhaustive testing now. And this is basically calculating a large amount of equations and getting a larger data set to work with here. So first we're going to be calculating 100 equations, so 10 times 10, and see how many equations we get correct or solved. Clear the terminal. We get 52 equations solved out of 100. Okay, so now we ramp it up. We have 10,000 equations to solve, and we get 460. And now for the final test, we have 1 million equations to solve. And we get 4,484. So now that we have all of these data points, we can put it in a graph. Let's take a look at it. Okay, so looking at the graph, you can see that the part 3, the line goes right over part 1, which is not that surprising because all of these are not supposed to be used independently. So in the end, we're going to combine all of them and check which part to use at what appropriate time. So part 1 might do something better than part 2 and be more efficient at taking a certain equation. And same goes for part 3. So as we look more into it and connect all the dots, we should get a more efficient engine at the end. Alright, so that covers everything for this video, and I hope you enjoyed it, and I'll catch you in the next one.